Hey guys, thank you so much for joining me on my third lecture of monitoring series. In today's lecture, we will be focusing on monitoring Nginx logs using Filebeat. So let's start. Core idea here is that we will be transforming plain Nginx log into a structure. When we have structured data, it's very easy to reason about it. For example, we can easily plot a graph which helps us whether the system is healthy or unhealthy. Here you can see we have our request distribution over time, breakdown by HTTP status code. I will show you how we can plot this graph in this particular lecture. But before we dive in, I would like to highlight few key points regarding why Nginx log monitoring is really crucial. One point here is that it helps us in performance optimization. For example, maybe you have some endpoint and you want to improve the performance. So how would you do that? There is some kind of a ground truth, right? So you have some data, and when you have data, you can easily compare whether the performance has improved or not. Another advantage is that it helps us in troubleshooting. For example, at my current company, we try to enrich logs with a user identifier, and this way we can directly see whether it's actually customer who is creating a problem or is it our internal service who is creating a problem. So at least it gives us some direction. So yeah, this is one example, but there could be many examples. Third point here is deprecating endpoints. What I mean by that, for example, you have very old endpoint and you want to remove it from your code base. How safe is it to remove that? With the help of Nginx logs monitoring, you can easily see whether this endpoint is being used by anyone, and if it's not used, let's say in the last maybe a month or maybe 2 months, you can directly see, oh, it's safe now to remove it, so let's drop it and clean it up. So yeah, this also helps us in identifying whether the endpoint is being used actively or not. So yeah, those were the few advantages besides health monitoring. So now, in previous lecture we have already seen Metricbeat, which helps us in collecting system metrics or MySQL module or MySQL metrics. So now we are using Filebeat. What's the key difference? Both are lightweight data shipper. They both offer numerous modules to facilitate collecting data. However, the key difference lies here that Filebeat collect data or metrics from the logs file. However, Metricbeat directly collecting data from the system, and this is the core difference. As I mentioned already, Filebeat also provide numerous modules, but the focus of this lecture is on Nginx module. So let's start monitoring then. Let's first go through the code. For example, this is the similar Docker Compose file which we have seen in the previous lecture. The only difference is that we have replaced Metricbeat with Filebeat. Since I am interested in collecting Nginx log metrics, so I have additional container for Nginx. Please note that all the log files are stored in this Nginx volume, and this volume is shared between Nginx and Filebeat so that we can collect the information. And as always, we have a configuration file for Filebeat, and as you can see here, I am using Nginx module and in particularly access metric set or file set here for collecting access log, but it also provide it also provide us a way to collect error logs as well via error matrix set. So yeah, those were the things regarding configuration changes. I will come to this point later, but first we can focus on the very basics. So let's dive in and we will see how we can plot a nice graph. When you open Kibana, you can already see that we have a matrix here. For example, the matrix may look like this. Original log, as I mentioned, would look like this, and then we have a structured data, response code, version number or method. So yeah, all good. And we are interested in plotting the graph then. As usual, we will be going to visualize library and then we will create a new visualization. In previous lecture, we focused on lens and aggregated based. So in today's lecture, we will be using this DSVB graph. So let's start. Okay, we already have data here, but we need to break it down with the help of we need to break the data with respect to status code, and for this we need to use this filters. And here we will be using HTTP status code. Here we go, and then greater than 200 and HTTP response for the status code less than 299. This means when we have this range, it is considered as healthy, so we say 200s, and then maybe we will copy it and replace it with different status code, say 300, 400, 500, etc. We can use different colors so we can easily distinguish it. Here it would be 400, here it would be 500, which is mostly related to server errors. Again, we will use different colors, for example this one, and here red, so that we can see it directly. And as you can see, the graph is ready, and we can easily adjust the legend, because I think it looks really nice here. So our graph is mostly ready, but when you are using it in production system, I would recommend to use these filters, maybe here or here, and this way you are only considering relevant data. So let's save this. Request distribution over time, and here we can say none. And yeah, it's just a single visualization, so I'm not using any tag, etc., and I don't have to add any dashboard, so it's just a simple visualization, no big deal. So there is another way which we can plot this graph. It's again using lens. As you can see here, we have a status code, and when we use this shortcut, we have already timestamp on x-axis, but what we can do is we can use here count, because we are interested in how many number of requests are in 200 or in 300, etc. So that's why we have used count on the y-axis, and we can call it requests. And since we are interested in status code, so we can break it down and we use this filter. For example, http dot again response dot status code, similarly greater than 300 and less than 300, and here we can say 300s. So we can now copy this, maybe 200, so here 400, and then finally 500. Just wanted to make sure that I did it correct. So yeah, we have this graph here, but we want some nice color scheme. So the difference here is that if you see this color palette, it has first green, then blue, then red. If we want 5500 to be red, then we need to place it on the third. And for example, if you want 2200 to be green, then we have to place it on the first position. And this way we are following this scheme, and we will have this graph accordingly. So I would be interested in area graph, and yeah, it looks like this. So far good. So we can easily save this again via demo request distribution over time. All good. So far good, right? Nothing to worry about. So the default Nginx module really works nice, but what if you really wanted to enhance it and enrich it with your custom fields? As I mentioned, we can also use it for performance optimization or for troubleshooting purposes. Maybe we want to segregate logs so that we can easily distinguish whether it's an internal service using these endpoints or maybe the customer using these endpoints. This means that we need to modify the log format, or somehow we need to customize a Filebeat Nginx module, right? So how we can do this? In order to understand this, we need to dive deeper into the module and understand its working, right? So this is something which I will be covering next, so that you can enrich as per your need. So let's start. So here is a rough diagram, I would say. We have a Filebeat and we have collected logs. So far good. But when the Filebeat collects the log or read the logs line, it directly sends those logs line as a raw entry to Elasticsearch. And this whole structuring is done at server side at Elasticsearch layer. What it does is it receives a raw log, and then there are some pipeline or processors that enrich this raw log into structured data and then finally save this data into Elasticsearch. This indexing here means that it's storing document in Elasticsearch. So that's how the whole process works. For example, the name of the pipeline is called ingest pipeline, and it has some processors, for example set, rename, etc. How this processor work? The execution starts from top to bottom, and it will try to enrich data in each step. That's how it looks like. For example, you have a raw log line, you have a processor that does some processing, enrich this information, forward it to next processor, then it will do some processing, forward it to next, and so on and so forth until you have the structured data. That's how the pipeline works. Real world example, as I mentioned, that you can enrich it, for example, with the username or email or maybe response time, etc., so that you can easily optimize your endpoints if you need. So let's look at the demo. So it's actually twofold, which means we first need to modify the log of Nginx, log format of Nginx logs, so that we have this information at least in the logs, and then we need to adjust the ingest pipeline. Let's say we want to monitor request duration of our endpoint, and that's the field which can be used to get this information. Once we have this information, we can enrich the pipeline, and yeah, everything would work. So if you see here, if you pay close attention to this particular pattern, it matches exactly with this format, and that's why I have added explicitly here access.x underscore forwarded underscore for, because it's here and it was not mentioned before, because the whole pipeline or the whole pattern was working flawlessly, because we were only monitoring these few metrics and we were least bothered about this one. And since I don't want to break the pattern, that's why I added it at the very end, and that's why now I have to consider this as well. So rule of thumb, whenever you want to roll out in your production system, always start with modification of log files, deploy it, and then modify the ingest pipeline. This way there won't be any breaking changes and you won't miss any metrics at all. So now we see everything here, and in order to automate it, I have used this container with a curl image, and what it's doing is it's actually sending a request for updating this ingest pipeline to Elasticsearch. So this is actually the endpoint or the base URL for Elasticsearch, and you can always find this on official documentation how to update ingest pipeline, and that's how it's done. So I'm just updating it here, and log file is ingest pipeline file is in the repo, and you can always refer this here. And now I can show you how we can also see this information in Kibana as well. So we can easily see it by going through stack management, and then here we have a ingest pipeline, and within this we have several pipelines, but since we are focusing on access logs, so we need to go through access pipeline, and here you can always modify or whatever, and you see here we have set of processor, and yeah, right now it's maybe this processor which we are using, or maybe this one. Yeah, I think this one is the one which we are using, and we need to modify this one. So when I apply this, we will see that this has changed it will change automatically. So let's apply it. And in case if you are not sure what this processor is doing, so don't worry, you can click here and you can always see or refer documentation here by clicking here. So nothing to worry about. So you see here I am now starting a container to apply this pipeline, and we have already applied it successfully, because here it says acknowledge true, which is a successful response. So let's check the now pipeline whether the changes are getting reflected or not. We can directly see it by observing the matrix, because now the information is available over there. So we need to refresh it, and as you can see we have this information already available here at the end, request underscore time. If I refresh the page, I'm sorry, I was wrong. It was the third grok processor and not the fourth one, so I did a mistake in the previously. So now let's see the matrix. We can directly see it here, request time. We see that the information is available, but it was not available here, you see here, but now it's available. Since it's a local host, so no big deal, so everything is very fast, and we can directly plot the graph with the help of this field. And yeah, so you can click here, you can say visualize, and if you want you can directly plot the graph. For example, P99 percentile 99, and then here you can say duration, but it's always 0 for us, so the results are not interesting. So yeah, that is it from my side. I hope you like this lecture so far. So there is one important point here. When you are using your production system, what are the best practices? Filebeat module allow you to specify explicitly ingest pipeline when you are using any specific module. What this mean? Let's say you are just starting out, so don't over engineer it, and you can use a standard ingest pipeline. But let's say you have very many applications, and somehow one of the application may require different log format and you want to customize it, then I would highly recommend that you use dedicated pipeline for that particular application. And you can do this by specifying explicitly here custom pipeline or dedicated pipeline for that particular app. This way you are separating the concern, and it's a recommended practice from my side. So yeah, that is it all for this lecture. I hope you're enjoying the lecture, and if you have any questions, never hesitate and feel free to ask in the comment section. See you soon then. Bye.